Hello everyone, I am Nitanshu. I am a software consultant and I have around 7 years of experience dealing with different backend technologies. I help startup create new features, mainly backend features, optimize them, create new APIs, scale their software, and all of that stuff. I've spent a fair amount of time dealing with optimizing different backend technologies, like different backend APIs, and I've noticed some patterns that keep on reoccurring, and I've derived a set of questions that I ask myself while optimizing a backend API, and that's what I would like to share to you in this video. Uh, First of all, before we even start into this, I need to tell you about why do we even need to optimize backend APIs and going forward. So when a user makes a request, it hits your backend servers, backend application, the amount of time it takes to process that request by your backend and return the response back to the user, that is your backend processing time, and that is the time which we want to reduce, because this reducing this time will lead to an increased user experience. I think you all would agree that even if a product is good but the user experience is bad, that means the product is slow. When you click on pages, it keeps on loading. I think that would be the most painful thing ever after a slow internet connection. And yeah, other than that, I mean, if you optimize your backend APIs, that means it increases the efficiency of that API. It will be able to cater to more amount of requests using less time and less resources. And that would decrease the cost of your infrastructure. It will lead to more stability and scalability. And that means your backend can handle more load and more requests for less amount of cost that you're spending on your infrastructure and all of that. So I think now that we can move towards the meat of the presentation. Moving on, the agenda will be I'll be talking about few performance measuring units and different tools that we use to analyze the APIs and their performance, and different optimization techniques and the patterns to look for while you are optimizing. In order to improve something, we should first be able to measure it. So if you want to improve your backend APIs, you want to know where you stand currently and where you want to get. And only after you have these measurements, you will be able to reach your goals. In order to do that, let's talk about few performance metrics. And I think latency is the one which we'll be talking about the most. And latency, as I told you, latency is the amount of time it takes from when the user or the client sends a request to your backend, amount of time it takes your backend to process that request and returning that request. So all this time, it's called the latency of that request. When we talk about performance, the performance of an API is defined based on two terms. One is the latency, the amount of time it takes, as well as the amount of resources that API is consuming, the memory and CPU. But for the scope of this presentation or video, I'll only be talking about latency and using the term performance and latency interchangeably. But as a bonus, sometimes you can also get resource benefits, like when you are improving your API, it will reduce the amount of memory and CPU that uses based on that particular use case. But we'll not be talking about this as of now. You can break down latency into percentiles, and the terms that we use are P99, P95, P90, P75, and so on. For the sake of this presentation, I'll only be focusing on P90. So what does P90 or the 90th percentile, 95th percentile actually mean? When I say this API has a P90 latency of 200 milliseconds, that means that 90% of the requests were served within 200 milliseconds, and only 10% of the requests were served above that. P90 is a good measurement to aim at when you are just starting out to optimize your APIs, something good to aim for. But if you are like serving 90% of your users within 200 or whatever threshold you set is a good benchmark to start with. But as you keep on optimizing, I think, and you're aiming for excellence, P95 and P99 are the things which you should aim for. Other than that, I think what latency is actually good. Is 1 second response time good? Is 100 milliseconds good? Is 500 milliseconds good? What does it mean in terms of user experience? So when I say that a latency or is 0.1 second or maybe 100 milliseconds, the user will feel that the response time is instantaneous. It would be just flawless. When the latency of an API is around 1 milliseconds, so this is the exact point where users' flow of thought will remain in a steady flow, and once you go above this, it will start to interrupt. The user will start to notice a bit of slowness. And if it is around 10 seconds, then you will have all the users' attention waiting on your page to load. And this is where we use something like a loading screen to communicate to the user that uh, you're you're doing some kind of processing and the page is loading. This is not something very good. Other than that, you can see this graph with P50, P90, P90, P75 different kind of latencies. And moving on, yeah. So what you can expect after making these optimizations is, as you can see in this graph, this is a particular API and it had high amount of peaks. As you can see, some of these requests were hitting around more than 17 seconds. And after you make some kind of improvement, you can see how stable this graph is. This is around 250 milliseconds, and that's how you can expect your response time and your APIs to become more stable. You can also see in this graph how the memory usage has dropped a bit after optimizations are made. So you can see the particular memory container was using around 4 GB sometimes, or how unstable this graph was. Sometimes more than 8 GB or 5 GB, 6 GB, and the instability. And after an optimization is made, you can see how stable the memory usage is as well. And it's around 1 gigabytes of memory. So that is around more than a 4x drop in memory usage. And this directly means reduced infrastructure cost, better ability to handle load by your application. So this is one other example of that. You can see for this API, the P90 latency, which is this yellow one, was around 1 second. And after the improvement was made, the graph fell down by a lot, and the latency became stable, and it came to around 100 milliseconds. Given that there are few tools that are nice to have, very good to have, to measure your latencies, the one that I've used in this example is Datadog. Datadog is nothing but an observability service for your cloud applications. It provides monitoring for your servers, database, and all those tools you need. There are a substitute for Datadog, which I think you can use Elastic Application Performance Monitoring Stack. There is Prometheus with Grafana or New Relic, and I think Sentry also has these options. So it will just give you a nice dashboard, and you can monitor all your APIs and what request is taking how much time and all of that. Other than that, Django has this awesome tool called Django Silk, which is a profiler, and you can run it locally and you can monitor the amount of time, database queries, and all of that, which this is also a very good tool that I use. Other than that, you have this Django extension called Shell Plus, and this command you see on the bottom left corner, this print SQL command, it gives you a nice Python shell, a console where you can run your Django models or Django query set, and you can, for every single line, you can see which SQL command is getting executed. It just helps you understand your all the database queries that you are making. In case of Django, this is how it looks like. It will show you a dashboard with all your APIs and the amount of requests that API is making for a given period of time, along with the P90 latency and all of that. And once you click on an API, it shows you a nice view of how many requests. It gives you a small uh, subset of requests that were made live on your servers and amount of time it take to process those requests. If you're using other tools, it would be very similar to this. They will all have some kind of similar mechanism where you can observe all your requests. So while you are optimizing an API, going through all of this is not very nice to have. It gives you a very good view of what is actually happening in the API, which requests are slow, which APIs latencies are slow, and all of that. Once you click on a request, any of the requests, this particular tool like Datadog, it shows you a nice view of which is called this nice graph which is called flame graph, and this is something very important to know how to read it. So as you can see, this particular request had 37 milliseconds response time, and this provides a scale about from 0 to 37 milliseconds, and it tells you how exactly the request was executed. So you can see that this particular API took 37 milliseconds of time, and as you go down for it tells you which middleware was called, and in the end this is the most important thing to look into. It calls this REST framework API.dispatch method. So this is exactly the code which is getting executed in your view, the code which you write, and this is the amount of time it takes to execute all of that code. And this means when your code is getting executed, maybe you will be making network calls, maybe you will be making database calls. And as you can see here, this bottom line means it made a database call. This is the amount of time it takes for database to process that SQL query. It returned back the response. This is the amount of time it took your Django application, your backend application to process whatever data and make another SQL call, and so on. So it gives you a very nice view of what is happening inside your API. And this is something nice to have. Other than that, this is a flame graph. Yeah, so you can see here in this particular case that in the API view.dispatch method, it made an SQL call, but so much you can see this blank space. So this much amount of time was blocked in the application for some reason, and reducing this will reduce the response time of your API. And in this case, you can see it was 25 milliseconds, which is a lot. Other than that, your tool will also have a span list or sort of a thing which will give you a good idea of. So your backend can be using your backend can have the Django application running along with maybe a Celery task or Redis and an SQL database or something else as well. It will give you a good overview of what SQL queries were executed, how many queries were executed, how much time every query would take. And all this data is very important to get a good look of your API. Other than that, now moving forward to the patterns to look for while making improvement. So not a single rule will apply to every single API since the use case can be very different. But these are a good set of questions that you can ask while optimizing an API since the use case will be very, very different according to you. And using these patterns, you can figure out the places where the API is slow and could be slow, and then figure out how to improve that pattern, like improve that bottleneck, whatever it is. It would be very difficult to go very deep into every single pattern because it is such a vast scope, but I'll give you an overview which will give you a good direction to look into while you are optimizing your APIs. So I think the first question that you can ask is and know about is there a n+1 selects problem happening? And this is a very frequent thing which I have seen happen in different backends. And it usually occurs when code executes a large number of SQL queries for fetching data from the database. And it is very common with ORMs. So I'll give you an example what it is like. Imagine we have two tables, one is cars, another one is wheels. And the cars table stores a list of all the cars, and the wheels table stores all the wheels for that particular car with the foreign key of the car ID. So now you want to fetch all the cars and all their wheels. So what you will do is first you will make a SQL query to fetch all the cars. So you make the select star from cars query and it gives you n number of cars. Now because you want to fetch all the wheels of this car as well, for each car ID that you get from this previous query, you make another query, select star from wheel where car ID is that particular car ID. And if you do this for every single car, you end up with making 1 plus n queries. That means one query for fetching all the cars, and then n different query for fetching wheels of every single car. And this is very frequent when you are using ORM to fetch data from your database without the use of select related or prefetch related, depending upon your use case. And this is something which you should look into. Let's dig deeper into this with more examples. So this is one case of n+1 problem. So in this Datadog dashboard, you can see when you are tracking your request, maybe one or two or three or more SQL queries, different SQL queries are being made repetitively. So this particular SQL query was made more than 2,000 times. And that indicates that's a good indicator to find out, like to figure out that this could be due to this n+1 problem or the lack of using select related or prefetch related, which are provided by Django. So yeah, in this example, you can see that I was working on one API which had this problem, and this is a screenshot of Silk, Django Silk. And before making the optimization, this API was using around 3,000 something queries. And after the optimization, it reduced to 76 queries. So you can see how big the improvement could be and how drastic the reduction in queries could be due to just this simple thing. So let's talk a bit about select related and prefetch related, but I would highly recommend you go through the Django documentation and read more about it to understand it deeply. Select related is something which you use mainly when you are selecting a single object or you have a one-to-one relationship between two models. And prefetch related is when you use to get a set of things, when you have a many-to-many relationship or a reverse foreign key relationship between two models. Usually what a select related does is, for example, in that example of cars and wheels that I gave you, if we would have made a join between the cars and wheels table, we could have fetched it in a single query. And that's what a select related does. It makes a join for you, but you have to tell it using that particular select related phrase in the code so that it can actually know to make the join instead of fetching all those uh, rows separately. What prefetch related does is it can be used where select related is not. It works a little differently than select related, and it performs separate lookup for every relationship and then rejoins them within the Python execute, like within the when the Django code is executing instead of making the join in the database. And I've seen this repeating so much that I don't know why developers don't use this enough. But I think a good whenever you are writing code, it is a good practice to always think where can you use these and write them in and use them instead of just being mindless about it. Moving on, I think let's dive deeper into this with an example. So let's say we have a author's model and a book model. If you want to select all the books, ideally you would make this books objects all query to fetch all the books. And if you want, when you want to print the title, you will call a for loop on all these books and call the title an object. And as you can see, the author is a foreign key on this books model. So in that case, when you will do it, the first query will be select star from books to fetch all the books. And when you work on the for loop for each and every book, it will make this query select star from author where ID is book.author underscore ID. And this is exactly that n+1 problem which happens. And this can be mitigated when you use the prefetch related phrase. So on that same example, select related phrase. So in that same example, if you would have select related the author while fetching the books, that's what it will do. It will execute a single query with a join on that author's table. And you will be able to print all the books with just 2 database queries, if that makes sense. So you can see how drastic the reduction is. Other than that, the case of prefetch related, in this case, we have similar models and we have a foreign key on author. And when you're using prefetch related, it's used to deal with many-to-many or reverse foreign key relations. So let's say you are fetching all the authors and you want to prefetch the book set in this case. And for every author, you want to print the title of that book and the name of that author. So in this case, when you are using prefetch related, this will execute 2 separate queries. But in this case, Django will also efficiently map the results for better performance. So the first query will be to select all the authors from the table. And the second query will be more efficient. And other than making all these 2 different queries, Django will do some application level optimization to fetch this data, like make this operation performant. I think there is a lot more into it, and this is something which you should read more about in Django documentation to better actually understand it, because this few minutes of presentation won't do much justice to it. But I think it gives you a good gist of what these operations do. Moving on to the next pattern or the problem that could occur or thing you can look into is ask yourself the question that, can I remove redundant data from the API response? And I think this is one of the most easiest thing to do and very much overlooked. So what you can do is you can just talk with your front-end engineers or take a look at your front end and figure out what data the front end is actually consuming. And I think when you are working with startups mainly, or when you are working focused on feature development, these are the things which you neglect a lot. And because you are building new features and deprecating the old ones, it becomes difficult to remove what data is not being used. So your backend is serving a lot of data to front end, but not all of that data is getting used by the front end. So talk to your front end engineers or figure out yourself which data is not getting used and clean up your serializers. And this is a very low hanging fruit, but for this particular API, as you can see, just making this improvement decrease the latency of this API by a lot. And I think this is something to keep in mind while optimizing the APIs, because this can be one of the things where you can look into to make the optimization. Other than that, you can think of, can I optimize the serializer? So the thing is, the model serializer is slow and I cannot go deep into it, but there is this great article about it and you can read it on your own time. But the model serializer does a lot of validations so that you don't have to write code for it. And sometimes there are cases where you don't actually need to use the model serializer. So the things you can look into is, if your API is slow and it is using a model serializer, first, if there are read-only fields, the fields which you are not writing to in the mod for the model or the serializer, mark those fields as read-only so that the separate validation for it is not performed and it should improve your performance by a bit. Other than that, use a regular serializer wherever possible, because if the model serializer is not needed, don't use it. It will increase the processing time of your application. And go through this article. I cannot go into it because the time does not do justice for this, but if you, I'll link it into the description of this video. uh, Other than that, you can ask a question that, are my APIs complex or unpaginated? And this is something which I've also noticed happen a lot, that when a feature or when an API is present, you want to serve more data to front end, you just keep on adding things to the same API. And with time, the API can get degraded by a lot. It can become more complex. You will be serving data which is not needed, or you will be serving a lot of data in it. So for example, on left, you can see how this API looks. And you can see it has first name, last name, the ID, as well as an array of data objects that we are returning. Now, in this case, how this API is designed, because of that, it is not possible to paginate this array of objects. And this is not following the JSON API specifications, which I highly recommend to follow while designing your APIs. And in this case, how the optimization was made was, we had to break down this API so that we can actually paginate it and break it down into two separate APIs. And because if you don't need to return hundreds of results or all the results in one go, it's better to have an API and just return 10 of the results which your front end will be able to show to the user, and then make another call to show the next 10, and so on. I think this is very obvious, but it gets neglected. Other than that, also have small atomic APIs to just serve whatever the data is needed. You can have multiple APIs, different APIs serving different parts of data, instead of a single API which has high response time to uh, serve all that data in once. So that is something which you can use, because your requests from front end can be parallel or asynchronous. That will reduce the response time by a lot. Other than that, yeah, follow the JSON API specifications. Here's the link for it. Always follow JSON API specifications wherever possible. This is one of the examples where the API was complex, and just by refactoring it, breaking down a complex API into 2 or 3 different APIs, how the improvement was made. And this is exactly where the memory drop also happened because of it. Other than that, another question that you can ask is, are your database queries slow? Like while looking into your API, these are the things you can ask, and one of them is look into if your database queries are actually slow. And it can happen in an API that it could be making multiple or a single SQL query, which could take a lot of time to execute in the database. And this a good way to do it is take a look in your data, like Datadog or application performance monitoring software. They usually have a good section for the all the SQL queries that happen and the amount of time it took for them to execute. Other than that, you can use Cell Canet's profiler. It will give you a very good idea of which line executed which SQL query and how much time it took. What usually causes the database queries to be slow is maybe a lack of index on the right column could cause the query to be very slow. If that is the case, look into where the index is needed and put an and create an index. Other than that, your database query could be making an unnecessary join with a very large table with millions of 100 millions of 200 millions of records, and that could cause the query to be slow. You can maybe break that query down into two queries and see how it goes. And there are so many things you can do to optimize the query, and it is very specific to that particular SQL query. What I usually do these days is I find out which query is slow. I just first thing I do is I paste that into Chat GPT to actually show me what the query is, explain to me what the query is doing if that query is complex. And I also ask it sometimes to optimize that query for me. So I get a good idea of, even though ChatGPT is not that accurate, but I get a good idea of where I can look into the query and make optimizations if possible. As you can see in this example, in the flame graph, in the last line when the view is executing, you can see it is executing multiple SQL queries, and this particular SQL query is taking a lot of time. So this gives you a good idea of for this particular API endpoint. Maybe if you can optimize this query, it would decrease the execution time by a significant chunk. And then you can maybe look into other places where you can improve this API. And that's how it would usually go. You would look into all these patterns and make these small improvements or big improvements, and you'll get the good results. Other than that, another question that we can do is, can I make things asynchronous? So when you have code in your view, and you are executing things, you're making you don't there could be things that could be done asynchronously, maybe using a celery task or something else, some other asynchronous task that could happen. Maybe you are doing some processing on database which the user does not need to wait on. It does not need to be real time. So it's it is a very good process to don't block the request thread unnecessarily. Just make an asynchronous request and let the thread continue so that the thread can execute and get back to the user with the response as soon as possible. And you can do all that processing that you want to do asynchronously. And this is something which I've noticed happening a lot, because when multiple people are working on an API, they are adding multiple lines of code within their view and the processes which are happening, and then they don't keep track of the performance cost of their whatever the processing they are doing. And if you are sending an email, never make it synchronous. Always make it to be an asynchronous task, and many different things which would be unique to your API. Another question that you can ask yourself while optimizing the API is, will caching help? So I think as the last step, what I look into is, after doing all these optimization in the database and all these things which I talked about, I look into if this API can, like, the performance can be helped with the cache. if this is a kind of API that is repeatedly used and serving the same type of data to a user or multiple users, maybe a cache would be a very good thing to add so that we don't have to hit the database for fetching the same data. Just store it in the cache and it would be very fast to do it. This would depend on the kind of endpoint and the frequency at which the endpoint is being hit, the use case of that endpoint. But this is something which you can keep in your mind and look into while optimizing the API. One of the questions to ask. I think those were all the patterns that I think I mostly covered all of those. But yeah, now we have the question, what are the problems after optimizing the API? What are the problems that we face once the optimization is done? This is not in the scope of this video, but just something to think about. And I think the biggest problem is maintaining those improvements which you have made. So keeping all those improvements to stay as where they were. I think it is a good practice to monitor your APIs constantly so that you can know if any feature was because multiple people will be developing on your APIs based on your use cases. You need to actively monitor those APIs to make sure any kind of new feature is not degrading that API and things like that. You need to have benchmarks for your APIs and have alarms set up so that they don't go above it. And if they go, you need to look into why they are above that certain threshold. Other than that, yeah, just be mindful and aware while developing new features and make sure all your developers are also mindful about it, the cost of whatever lines of code they are adding. This graph is one example of after we made that 1 GB, that memory drop which happened, and a new feature was released which caused a spike in the memory. So be cautious about it. And I think that would be it. Yeah, that's the end of the presentation. Thank you for listening. I would love to hear what you guys think about this. And if you would definitely have more ideas and things to share about, please let me know. And you can reach out to me on email in case you need any help or want to talk about anything. My email is netanshu.dev@gmail.com. And yeah, thank you for watching this.